finding the inverse, how to find out the inverse. We have discussed some results also. What are the results we have discussed in the previous class? So the first result in based on adjoint of A into adjoint of A and adjoint of A into A is equal to determinant of A into identity. This result we have discussed. Okay. And the second one is the definition. Second one is the definition. Definition is singular matrix. A is singular. The matrix A is said to be singular if determinant of A is equal to 0. If A is non-singular, if determinant of A is not equal to 0. Okay. And the third one, if A and B are two non-singular matrices, A and B are non-singular of same order, if A and B are non-singular of same order, okay, then the AB and BA both are also non-singular. Okay, of same order. Okay, this is also we have discussed in our previous class. Okay, and another one, if A and B are square matrices, if A and B are square matrices of same order, order means the same order means both are ordered having 2 cross 2 or 3 cross 3 like that, then determinant of AB equal to determinant of A into determinant of B. Determinant of AB is equal to determinant of A into determinant of B. Okay, this is the fourth result we have discussed in our previous class. Another result we have discussed, determinant of adjoint of A is equal to determinant of A the whole power n minus 1. Okay, where A is the matrix of order n. Matrix of order n. Okay, right. The sixth result, A is invertible. What is the invertible? Invertible means inverse exists. When inverse exists, if A is non-singular, if and only if A is non-singular. Okay, right. So what is the inverse formula? A inverse is equal to 1 by determinant of A adjoint of A. Right. So this is another result. And yesterday we have discussed one more result, AB the whole inverse. A and B are invertible matrix, then AB the whole inverse is equal to B inverse into A inverse. Okay, so these things we have discussed in our previous classes. Okay, right. So we have discussed problem also. If you have any doubt means you please send a message in chat box. Okay, you chat your doubts. I will explain. Okay, so take a next problem. We have discussed some problems in our previous class. Now we are going to discuss about some more problems. If your A is equal to 3, 1, minus 1, 2. Okay, then show that A square minus 5A plus 7I equal to 0. Hence find A inverse. Hence find A inverse. How to find out A inverse? But look at that, this is a very important point. Hence, find in A inverse means using this result, you have to find out inverse. That means using this result, you have to find out A inverse. Don't apply this formula. What is this formula? 1 by determinant of A adjoint of A. Don't apply. Don't apply. Okay, because we have, if the question is find A inverse means no problem. So to show that this result and hence means use this result. That is the meaning. Using this result, find the A inverse. That means based on this result, using this result, derive the A inverse matrix. Okay, how to find out the A inverse matrix? Okay, look at that. Here A square minus 5A plus 7I is there. We know I is identity matrix. Since A is 2 plus 2, you can take it as I is also 2 plus 2. Here A means this matrix. But this is we don't know. A square, find out. What is your A square? Your A square is A into A. What is A? A is 3, 1, minus 1, 2. Here also 3, 1, minus 1, 2. Multiply. So what is the answer? So first row, second column. Okay. First row, first column first. First row, first column. Row by column multiplication. 3 into 3, 9. 1 into minus 1, that is minus 1. 9 minus 1, it is 8. Okay. And this is 3 ones are 3. And this is 1 into 2, 2. So therefore 3 plus 2, it is 5. 3 plus 2, it is 5. Okay. And this is minus 3 and minus 2, that is minus 5. And this is minus 1. This is minus 1 plus 4. So that answer is 3. Okay.
doubt இல்ல சார் ஒரு தியரி தான் சார் தியரியில பாருங்க மார்க்ஸ்க்கு மார்க்ஸ்
Okay. So this is your A square 8 5 minus 5 3. Okay. So this is your A square. Now apply that. Come to that the LHS. What is my LHS? A square minus 5A plus 7I. So therefore A square minus 5A plus 7I equal to, what is actually my A square? My A square is 8 5 minus 5 3. Okay. Minus 5 times of A. What is A? 3 1 minus 1 2. Okay. Plus 7 times of I. What is my I? 1 0 0 1. Okay. So therefore the answer is, so A square is 8 5 minus 5 3. Okay. And this is, you just multiply this minus 5 here inside. Okay, apply minus 5. That is multiply minus 5 to all the elements. Therefore, the answer is minus 15 minus 5. This is plus 5. This is minus 10. Okay, plus multiply this 7 inside. Therefore, this is 7. This is 0. This is 0. This is 7. Okay, so now add these three matrices. How to add these three matrices? So look at that, first element, first element, first element. Okay, add this 8 minus 15 plus 7, the answer is 0. Second element, that means second element, corresponding elements. The matrix addition is add the corresponding elements. 5 minus 5, 0. Okay, here minus 5 plus 5, 0, 0. And 3 minus 10, 7, that is also 0. Okay. So the right hand side we are getting the 0 matrix. 0 matrix means that is denoted by capital O. This is not 0, 0 matrix, capital O. Okay. So therefore, what is the left hand side? My left hand side is A square minus 5A plus 7I equal to 0. So this is the answer. Now the question is, next question is find A inverse. How to find the A inverse? Using this, that is an important point. Don't use this formula. Hence, find A inverse means use this formula, this idea, A square minus 5A plus 7I equal to 0. Using this, find A inverse. Completed means we'll go to the next slide. Go to the next one. So, to find A inverse, okay, what is the given? That means known result A square plus minus 5A plus 7I equal to 0 matrix. Okay, I'm going to multiply by A inverse for all the terms. Post multiplication means here A square into A inverse minus 5 into A into A inverse, and this is 7I into A inverse. This is 0 into A inverse. Multiply all the terms by A inverse. Okay, so this is where A square can be written as A into A inverse. Okay, now look at that. What is the A square? Well, A square is A into A. Okay, and what about your A into A inverse? That is identity. The matrix and its inverse multiplication is identity. What is about identity into any matrix? Multiplication of identity into any matrix, that is A only. Okay, zero matrix into any matrix, that is zero matrix only. Okay, another important thing, the associative property A B into C is equal to A into BC. We can write like this. That is associative property is also true. Okay, so that I'm going to apply all these properties. These are the properties of matrix multiplication. I'm going to apply that multiplication and the inverse. So therefore A into A inverse is my identity. My plus this is I into A inverse is my A inverse. Right hand side 0 matrix into A inverse 0. So now I'm going to change this A into A inverse minus 5 times of I plus 7A inverse, okay, equal to 0. Right? So therefore, what is for A into A inverse? For A into A inverse is identity. This is identity. So therefore, A into identity minus 5I. Okay. And this is your plus 7A inverse become to the right hand side minus 7 times of A inverse. Okay. What is for A into I? That is A only. But A into identity. Identity into any matrix, that matrix itself. Therefore, A matrix in one way. So therefore, apply A. What is for A actually? What is for A? A is 3, 1, minus 1, 2. So A is 3, 1, minus 1, 2. Okay. What is my identity? Identity is 1, 0, 0, 1. Okay. So this is equal to minus 7 times of A inverse. Right. So therefore, this is just subtract. So that is 3 minus 5. You multiply this minus 5 here, this is minus 5, 3 minus 5. What is the answer? 3 minus 5 is minus 2. And 1 minus 5 into 0, that is 0. After multiplying minus 5, we are getting 0 only. 1 minus 5 into 0 is 1 only. Okay. And this is minus 1 minus 5 into 0, that is also minus 1. Okay. And 2 minus 5. 2 minus 5 means that is minus 3. So therefore, this is minus 7 times of A inverse. So therefore, minus 1 by 7. Bring this minus 7 to left hand side because I need only A inverse. Minus 1 by 7 of minus 2, 1, minus 1, minus 3. So therefore, this is my A inverse. Okay. So you just multiply this minus inside to all the elements by minus. That is, here minus means it will become plus 2. Here minus 1. It will become plus 1. It will become plus 3. This is your A inverse. Okay. Please notice your A inverse is 1 by 7, 2 2 minus 1, 1, 3. Okay, right. How to verify your answer is correct or not? So we know that the formula, this is for verification. 1 by determinant of A adjoint of A. Okay, what is determinant? This is actually A. Okay, what is the determinant of this A? 3 into 2, 6. This is minus of minus 1 plus 1. So therefore 6 plus 1, it is 7. Determinant of A. Okay, what is adjoint of A? Adjoint of A means interchanging these two elements, 2 and 3. Okay, and sign change of these two elements, that is adjoint of A for 2 plus 2 matrix. Sign change. So therefore here it is plus 1, here it is minus 2. Okay, so therefore this is 1 by 7, 2 minus 1, 1, 3. Okay, so the same answer we are getting here. 1 by 7, 2 minus 1, 1, 3. This is the A inverse. So this is the easiest formula for 2 plus 2. You can easily find A inverse. But the question is given, hence find means using this result only you have to find out A inverse. This is the method. Multiply by A inverse and simplify, you will get some A inverse term. Keep it that A inverse term one side, keep other terms to the other side. Okay, and then simplify. So therefore we are getting this answer. Okay. Please take it, we will discuss some more problems in the same time with the 3 cross 3 matrix. Okay, yeah, come to the next problem. This is also some exercise question. The same type of question. If A is equal to 1, 1, 1, 1, 2, minus 3, 2 minus 1, 3, show that, the question is show that A cube minus 6A square plus 5A plus 11I equal to 0. A cube minus 6A square plus 5A plus 11I equal to 0. Hence find A inverse. Hence find A inverse. This is an important word. Hence find A inverse. Hence means use this result only. Hence means use this result. That is the meaning. Okay. Right. So we know that I is a 3 cross 3 matrix. Since A is a 3 cross 3 matrix, your I is also 3 cross 3 matrix. This is 1, last column 1 minus 3, 3. First column 1, 1, 2. Second column 1, 2 minus 1. Third one is 1 minus 3, 3. Right. We know that identity, we know that A, this is given matrix is A. We have to find out A square, we have to find out A cube. A square is nothing but A into A. Where A cube is nothing but A square into A. Okay, what is my A into A? That is 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. Okay, this is 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. Right. How to multiply? The matrix multiplication. Okay, first row, first column. So therefore, this is 1, this is 1, this is 2. 1 plus 1 plus 2. So therefore, the answer is 4. A square. Similarly, I am writing directly, you please try to understand. So this is 1, this is 2, Okay, 1 plus 2 minus 1. So therefore the answer is 2. Okay, and this is the net first or third column. This is 1, this is minus 3, this is plus 3. So therefore the answer is 1. Matrix multiplication is a very simple one. That's why I am writing directly, because we have already discussed many problems in the third chapter, matrix multiplication. Okay, and second row by third column. Second row by third column means this is 1, this is 2, this is minus 6. So therefore 1 plus 2 it is 3, this is minus 6, plus 3 minus 6 means it is minus 3. Okay, and this is 1, this is 4, 5, this is plus 3. So therefore it is 8. Everything is in plus, it is 8. So therefore this is 1, this is minus 6, this is minus 9. Minus 6, this is minus 9. This is 2 into minus 3, that is minus 6. So therefore, so this is minus 6, minus 9, that is minus 15. 15 minus 1, it is 14. Therefore, minus 14. Okay, and third row, first column, this is 2, minus 1, plus 6. So this is 2, minus 1, 2 minus 1, it is 1. 6 plus 1, it is 7. Okay, and this is 2, minus 2, it is 0. This is minus 1 into 3, minus 3. And this is 2 plus 3 and plus 9. Okay, 2 plus 3 and plus 9. So the answer is 14. So therefore, this is my A square. Right. What is our A cube? My A cube is, why I am finding A cube? I need A cube. What is the A cube? A square into A. How to find out A square into A? Just multiply, that is 4 to 1. Minus 3, 8, minus 14. Okay, and 7, minus 3, 14. This is my A square. Okay, what is my A? My A is, this is 1, 1, 1. Right, 1, 2, minus 3. And 2, minus 1, 3. Okay, so therefore A square into A, right? You multiply this. So you will get the answer 871 minus 23 minus 27 minus 23 plus 27 minus 69 and 32 minus 13 32 minus 13 58. Okay, so this is a homework for you. You please try to complete this A square into A and try to verify this answer. A square into A is 871 minus 23 plus 7 minus 69 32 minus 13 minus 58. Okay, right, now come to that the LHS. This is A cube minus 6A square plus 5A plus 11I, and prove that the right answer is zero matrix. If you are getting zero matrix means your answer is correct. Okay, so therefore A cube minus 6A square plus 5A, A cube minus 6A square plus 5A plus 11I. So don't put it as 0. We have to prove this as 0. What is the A cube? The A cube is 8, 7, 1 minus 23, 27 minus 69. Okay, 32, 13, 58 minus 6A square. What is for A square? 4 to 1 minus 3, 8 minus 14 and 7 minus 3, 14 plus 5 times of A. What is our A? A means a given problem. 1, 1, 1, 1, 2 minus 3, 2 minus 1, 3. Okay, 11 times of I. What is your identity matrix? I 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so this is the identity matrix. Now add everything. How to add? So this is, look at that. This 8 into this minus 6 into 4, this element, and plus 5 into 1, this element, and this 11 into 1, this element, first element, add the first element. What is the answer? Here plus 8, here it is minus 24. Okay, here it is plus 1 into 5, that is 5. Here 11 into 1, that is 11. Okay, what is the answer here? So this is 11 plus 5, that is 16. 16 plus 8 plus 24. Plus 24 minus 24, you will get 0. Okay, come to the next one, second element. This is 7, this is, and this is, and this is. What is that? This is 7 here. Okay, minus 6 into 2, minus 12. Okay, and 5 into 1, that is plus 5. This is 11 into 0, that is 0. What is the answer here? 7 plus 5, it is plus 12, minus 12, it is 0. Okay, come to the next one, third element. So this third element, adding. Addition of matrices is addition of corresponding elements. So therefore that is 1. Here minus 6 into 1. Okay, so therefore minus 6. Here 5 into 1. So that is 5. Here 11 into 0. That is 0. What is the answer here we are getting? What is the answer we are getting? So 1 plus 5 it is 6. 6 minus 6 it is 0. So therefore here also it is 0. Here also it is 0. So same in the same procedure you have to apply for the second row elements, third row elements. You get the answer is 0, 0, 0, 0. Okay, here also 0, 0 and 0. Okay, so therefore finally you will get it as 0 matrix. What we are getting, that is 0, 0, 0, 0, 0, 0, 0, 0, 0. That is 0 matrix. This is nothing but 0 matrix. Okay, so therefore your A cube minus 6A square plus 5A minus plus 11I equal to 0. Okay, so this is the answer. Okay, but the next question is, using this find the A inverse. Using this we are going to find the A inverse. Please take that. We'll go to the next slide and find the A inverse using this equation A cube minus 6A square minus 5A plus 11. Okay, so come to the next slide. We will discuss about finding A inverse. To find A inverse, what is known to self? A cube minus 6A square plus 5A plus 11I equal to 0 matrix. So multiply by A inverse both the sides. Therefore, this is A cube into A inverse minus 6A square into A inverse. Okay, and this is 5A into A inverse. This is plus 11I into A inverse. Right hand side 0 into A inverse. So this is A cube into A inverse. You can write it as this is A square into A inverse. This is 6 into A into A inverse. This is 5 into A into 5A into A inverse is identity. Okay, plus 11 identity into any matrix, that matrix itself, that is A inverse. This is 0 matrix. 0 into any matrix is 0 matrix. Okay. This is A square into A inverse. A square in A into A inverse. We can change. Okay, using associative property, we can change the bracket. So therefore, A square into A inverse. That is A square into identity minus. This is also A into A inverse is identity. So 6 into A into identity plus 5y plus 11 A inverse equal to 0. Okay. So therefore, A square into identity is A square. A into identity is A only. This is 5y. Okay. But we need only A inverse. This term only having A inverse. Bring it to the right hand side. Minus 11 A inverse. Right. Now apply A square. What is our A square? We have already discussed our A square. What is our A square? So our A square is this 4 to 1. Okay, apply that. Apply that A square, apply that A, apply I. So what is our A square? A square is 4 to 1 minus 3, 8, 14. 7 minus 3, 14. Minus 6 into A. What is what A? 1, 1, 1. 1, 2 minus 3. 2 minus 1, 5. Plus I times of I. What is your I? Identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, that's equal to minus 11 times of A inverse. Okay, so now add these three matrices. This is 4, this is minus 6 into 1, this is 5, 5 into 1. Okay, so this is 4 minus 6 plus 5. So this 4 plus 5, that is 9, 9 minus 6, that is 3. Okay, so therefore, so what is that? This is 4 minus 6 and plus 5. So therefore 4 plus 5 is 9. 9 minus 6 is 3. So therefore add these three matrices. Okay. Right. What about here? 2. This is minus 6. Here it is 0. So therefore 2 minus 6, that is minus 4. Okay. And this is 1 minus 6. So therefore that results, this is 1 minus 6. So therefore minus 5. So similarly, subtract the second and add the second row elements, third row elements, and simplify. You will get the answer as, so this is 9, minus 9, 1. This is minus 9, 1, 4, minus 5, 3, 1. This is equal to minus 11 A inverse. Simplify. So the final answer is minus 1 by 11 half. Okay, bring this minus 1 to the left hand side because we need only A inverse. So therefore, B minus 4 minus 5 minus 9, 1, 4 minus 5, 3, 1. This is very A inverse. Okay, please note this. problem is the question is, if A is an invertible matrix of order 2, then determinant of A inverse is equal to the last question in that exercise. If A is an invertible matrix of order 2, then the determinant of A inverse is equal to dash. Some options are given. So we'll discuss the solution first. Okay, what is actually A inverse formula? 1 by determinant of A, adjoint of A. Okay, take a determinant. The question is determinant of A inverse. Question is determinant of A inverse. Therefore, I am taking determinant. That means the determinant of this is 1 by determinant of A, adjoint of A. Okay, right. Actually, 1 by determinant of A. What is actually adjoint of A? A11, A12, A21, A22. Okay. So this is right. So now just multiply this 1 by determinant A here. What is the answer? Right. So that is A11 determinant of A, A21 determinant of A, and A12 determinant of divided by determinant of A, A22 divided by determinant of A. Okay, right. Look at that. In this first row, 1 by determinant A is common. Here also 1 by determinant of A is common. Okay. So if any one row or one column having any common value means we can take it outside. So therefore, in first row also 1 by determinant of A, second row also 1 by determinant of A, we can take it as 1 by determinant of A the whole square outside. Okay, right. Why I am using my adjoint of A is A11, A12, A21, A22 because it is given. My A is only 2 cross 2 matrix. Order is 2. So therefore here the remaining is A11, A21, this is A12, this is A2. So therefore this is 1 by determinant of A the whole square into, this is nothing but adjoint of A. My adjoint of A determinant of adjoint of A. Right? So 1 by determinant of A the whole square. What is adjoint of A determinant? Determinant of adjoint of A is determinant of A the whole power n minus 1. My n is here, it is 2, order is 2. Okay, please note that this is the result. We have already discussed this result. Yeah, look at this result. Fifth result, determinant of adjoint of A is equal to determinant of A the whole power n minus 1, where A is the matrix of order n. Here given is A is the matrix of order 2. So therefore 2 minus 1. Therefore determinant of adjoint of A is equal to determinant of A the whole power 2 minus 1. Okay. So therefore determinant of A the power 2 minus 1. Okay. Right. So therefore here determinant of A is 2 minus 1 means 1. Here determinant of A the whole power 2. Your determinant of A is a numerical value. Okay, real or complex value. Cancel it. So therefore I get 1 by determinant of A. So therefore the determinant of A inverse is equal to 1 by determinant of A. Right? So therefore this is the answer. Please note that the determinant of A inverse is equal to 1 by determinant of A. This is for 2 cross 2 matrix. For 3 cross matrix also we will get the same determinant of A. Determinant of A inverse is 1 by determinant of A. Okay, note that it is an important point. In general, the determinant of A inverse is equal to 1 by determinant of A, where A is the square matrix of order n. For any matrix of order n, square matrix of order n, the determinant of A inverse is equal to 1 by determinant of A. If A inverse exists means, if A inverse does not exist, the determinant of A inverse is not possible. Okay. Let's come to the next problem. What is the conclusion for here? Determinant of A inverse is equal to 1 by determinant of A. Or otherwise, determinant of A inverse is equal to 1 by determinant of A. Okay, so this is true for in general. Determinant of A inverse is equal to 1 by determinant of A, where A is the square matrix of order n. A is the square matrix of order n. Okay, for any square matrix, the determinant of A inverse is equal to 1 by determinant of A. Right? Okay, another question, the question number 17 in that exercise. It's a very simple question. Let A be a non-single square matrix of order 3 plus 3. Let A be a square matrix of order 3 plus 3. Then determinant of adjoint of A. Determinant of adjoint of A is equal to dash. So just now I have told that determinant of adjoint of A is equal to determinant of A the whole for n minus 1. Fifth result we have already discussed. Okay, but here your n is 3 plus 3. N is 3. Okay, so therefore determinant of adjoint of A is equal to determinant of A the whole power 2 minus 1. Sorry, 3 minus 1, it is 2. Determinant of A the whole square. Okay, please note that. Another question, question number 14. Question is, for the matrix A 3211 is given. Find the numbers. Find the numbers A and B such that find the numbers A and B such that A square plus small a into A plus BI equal to 0 matrix. That 0 is 0 matrix, this is capital O. Not 0, it is capital O. 0 matrix. Okay. Right. If this is given A square plus AA plus BI is equal to 0, A is given. So using this result and using this A, find out the values of A and B. Find the value of A and B. That is the question. Here identity matrix we know that 1 0 0 1. A matrix means this is 3 2 1 1. Okay. But A square only we have to find out. Find A square and apply that and simplify, you will get the answer. How to prove this? So how to find out your A square? Your A square is A into A. What is your A? Your A is 3211. So this is also 3211. Okay, now multiply. So row by column. This is 3. Sorry, 3 into 3, 9. 9 plus 2, 11. Okay, so this is 3 2s are 6. 6 plus 2, 8. And this is 3 plus 1 is 4. And this is 1 into 2, 2. 2 plus 1 is 5. Okay, now given, what is given? A square plus AA plus BI equal to 0. Right. But look at this problem. In this problem, okay, in this problem, we are proving this. A square minus 5A plus 7I is, we are proving, we are taking left hand side and we are proving that 0, 0. But in this one, no need to prove that because it is already given, 0 matrix is given. Okay, so you have to find out the values of A and B. That means you just apply A square. What is your A square? 11, 8, 4, 5. Okay, and A into A. What is my A? 3, 2, 1, 1. Okay, plus B into I. What is my I? 1, 0, 0, 1. What is 0 matrix? My 0 matrix means 0, 0, 0, 0. Since all are 2 cross 2 matrices, you take this identity. My A is 2 cross 2. You take it as identity also 2 cross 2. You take it as 0 matrix is also 2 cross 2. Right? Now add that. How to add these 3 matrices? How to add these 3 matrices? That is 11 plus this is 3A. This is B plus B. Come to the second element. This is 8 plus this 2A. This is 2A plus 0. This is B into 0. That is 0. Okay. Right. Now come to this 4 plus A. So this is 4. This is A into 1 plus A. This is B into 0, 0. And this is 5. Okay, plus A. And this is B into 1, that is B. This is equal to 0, 0, 0, 0. The left hand side is also 2 cross 2 matrix. Right hand side is also 2 cross 2 matrix. So if the two matrices are equal, then the corresponding elements are equal. These two are equal, and this 4 plus 8, that is equal to equal. This 8 plus 2 is equal to 0, that is equal. Okay, so therefore I am going to consider these, comparing these two elements. 4 plus A is equal to 0, which implies 4 plus A is equal to 0. What is my A? My A is equal to minus 4, right? Come to this one, this term. 8 plus 2B is equal to 0. 8 plus 2B is equal to 0. What is my 2B? So that is minus, this is minus 8. Plus 8 becomes minus 8. My B is equal to minus 4. Okay, so therefore B is minus 4. A is also minus 4. Okay, please take that. I'm sorry, this is, it is not 2B. I'm sorry, this is actually 8 plus 2A. This is not B, this is A. Your B is 0 here. I'm sorry, please take this. This is 2A and this is 0. Okay, your B is 0 here. This is 2A only, so therefore this is not possible. This is correct. A is minus 4 is correct. Then what to do? Come to this one or come to this one. Okay, compare this. 5 plus A plus B is equal to 0. Right. 5. What is your A? A is minus 1 plus B is equal to 0. So therefore your B is equal. This is 5 minus 4 is 1. This one becomes here it is minus 1. So therefore, A is equal to 4, B is equal to this is 5 plus A plus B. Okay, 5 plus A plus B is equal to 0. So A is minus 4, substitute that. On to the next problem. I think this is not equal to 5. Here the multiplication of these two, this is 1 into 2, 2, this is 1 plus 1, 1. This is 3 only. I'm sorry, this is 3 only. Okay, this is 3. So therefore here also you will get 3. Right? So therefore this answer is 3 only. So 3 minus 4, this is minus 1, this minus 1 becomes plus 1. Yeah, this is the correct answer. Here it is 3 only. Because the second row and second column 1 into 2, 2 and 1 plus 1, 1. Okay, please note that. We'll go to the next problem. The next problem is find the inverse of this matrix 1 0 0. This is 0 cos alpha sin alpha. This is 0 sin alpha minus cos alpha. Find the inverse. Okay, you can use the same formula as usual formula. A inverse is equal to 1 by determinant of A adjoint of B. What is determinant of A? First of all, find the determinant 1 into, okay, multiplication of this minus cos square alpha and multiplication of these two with minus sin square alpha. Okay, minus take it outside. Here we will get minus 1. Minus 1 into cos square plus sin square is 1. So therefore the answer is 1. Okay, this is not equal to 0. Not equal to 0 means where A inverse exists. Okay, that is non-singular. A is non-singular. Right? Now go for adjoint of A. What is your adjoint of A? Your adjoint of A is A11, A12, A13. This is A21, A22, A23. This is A31, A32, A33. This is the adjoint of the matrix. Okay, find minus and cofactors. What is the minor 1, 1, M11? M11 means this element, minor of this element. Okay, so this is minus cos square alpha. This is minus sin square alpha. Okay, so therefore this is cos alpha, sin alpha, minus cos alpha. So what is the determinant value? This is minus cos square alpha, minus sin square alpha. So therefore the answer becomes minus 1. Okay, right, M12, this element. What is the minor of this element? The minor of this element means leave this column, leave this row. Okay, so 0 into this and 0 into this. So therefore the minor is 0. What about M13? My M13 is equal to this element, minor of this element. Okay, leave this row. Okay, leave this row and leave this column, third column. Right, so remaining 0 cos alpha, 0 sin alpha. Take the determinant, that is also 0. M21, what is this element M21? M21 means leave this row and leave this first column. Okay, and take the determinant of that 0, 0, sin alpha minus cos alpha. So therefore that is also 0. Why it is 0? I am going to take the minor of this element, leave this row and leave this column, taking the remaining 0, 0, sin alpha minus cos alpha. So therefore the answer is 0. Okay, similarly, find M22, this element. For this element, leave this row and leave this column. Okay, leave this column and leave this second row. What are the remaining? 1, 0, 0 minus cos alpha. Look at that. You please take that. 1, 0. Okay, 0 minus cos alpha. Okay, this is minus cos alpha 1. Okay, minus cos alpha. This is 0. Okay, right. Similarly, find out your M31, M32, M33, and based on this minor, find out the cofactors. Okay, after finding this cofactor matrix, that means adjoint of a matrix, apply here. The determinant of A is -1. Okay, but find out your adjoint of A. Okay, so try to complete this minus, remaining minus and cofactors, and apply that in the adjoint of A formula and try to complete this problem. Okay, so this is a homework problem. Try to complete that. And exercise 4.5 remaining problems are all of homework problems. We have discussed many problems. Some remaining problems are there that are all our homework problems. In our next class, we will go for the next exercise, applications of determinant, that is exercise 4.6. This is your next class. We will discuss. Okay. In our next class, we will go for the exercise 4.6, applications of determinants. The homework is exercise 4.5 remaining problems, and this problem also including, this problem is not completed. Please note that. I have found out only few minors. You have to find out the remaining minors, and using minus find cofactors, and using cofactors find adjoint of A, and using adjoint of A find A inverse. The question is find the inverse of the matrix. Okay. Yeah. Please take that and try to complete the remaining problems. Thank you all. Thank you. Thank you, all students.